Welcome to Topic 10, Circles. We're going to start with the equation of a circle. This formula is given to you on your formula sheet, and as you can see, it's sitting right here in case you just happen to forget what it is. Now, some of my favorite things about the formula sheet is it tells you everything you need to know. For example, HK is the center of the circle, and R is the radius. So we just need to plug these things in or take information from them. So I'm going to take this equation and I'm going to write it right below this. Now if you're sitting here taking the SOL and you're a little confused, one of the things you can do is just compare and contrast. So that's what I'm going to look at right now. So what I notice right off the bat is this is a minus sign and this is a plus sign. So I'm probably going to be taking the opposite for HK, which is my center, by the way. So here it's a negative h and it becomes a positive h. So I want to write -6. Now, the minus signs happen to be the same here, so I'm just going to copy the 1. I also notice that I'm dealing with r squared. So some number squared, radius squared, is 196. Now how do I get rid of a square in my equation? I take my square root. And when I take my square root of 196, I get 14. Now, I did mention that I really like my formula sheet. So when I look at my formula sheet, again, I can see this on the front of it, which talks about a circle. And why is that important to me? Because I can see that my radius goes from the center of a circle all the way to the outside. My diameter goes all the way across. So when I look at how these two things are related to each other, my diameter is equal to 2 times my radius. So in this case, 2 times 14 is 28. So now I've taken all the information I can from this equation of a circle. Let's go on to the next example. Now, I've put my equation right here so we can see it again. Write the equation of a circle that has a diameter with endpoints 3, -2, and 5, 6. Use the graph paper if necessary. Find the center, radius, and the equation, because if I'm going to write the equation, I need h, k, and r. So they gave me graph paper, and whenever I see coordinates on the SOL, I go ahead and I graph. So I'm going to graph 1, 2, 3, -2, and -5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Now, if I connect those 2 points, you can see that I will have this as my diameter. When I do that, I know that my center of the circle has to be somewhere along this line. So let's look. I know that just in case I have to pick it, I always draw it in. So let's see. There's another formula I have, which is my midpoint formula, because I'm looking for the middle to find my center. I take those 2 points and I add them together. 3 plus -5 is -2. -2 plus 6, and I'm pretty much, in case you're wondering, I'm separating them and doing 2 separate problems here. -2 plus 6 is 4. Now, -2, 4 is up here. That's not on my line, so I know that that can't be right. I'm going to divide by 2 because I'm looking for the middle. And so that would be the middle of this, -1, 2. Now, in case I wasn't sure about that, I can do rise over run to get from one point to the other and keep going to see how it's going. So to get from here to here, 1, 2, 3, 4, 1, 2, 3, 4. So 4 and 4. Let me check this one. 1, 2, 3, 4. 1, 2, 3, 4. 4 and 4. So I know that this is the middle. So this happens to be my HK. So I'm going to actually go to my equation right now and fill in kind of like my skeleton. X minus something squared plus y minus something squared equals r squared. Now I just found this. -1 becomes -1. Two negatives make a positive. And I just write in the number 2 here. Now the easiest way to find the radius is just to use this formula, like I just did it, +1 squared plus -2 squared equals some number. It's going to equal r squared actually. So I can plug in either point, and I'll probably plug in both in my calculator to show you how this is going to work. So first I'm going to start with this point, 3, -2. And we're going to plug that exactly as you see it into my calculator. Parenthesis, 3 plus 1 squared plus, parenthesis, -2 minus 2 squared. And what do I get? I get 32. So now I'm going to write this again. And instead of putting in 3, -2, I'm going to put in -5 and 6. And when I do that, parenthesis, -5 plus 1, close parenthesis squared, plus 6 minus 2, close parenthesis squared. Let's see what I get. And I get 32. These two match, so I'm just showing you that it doesn't really matter which 2 points I pick, which xy coordinate I pick, I get the same answer. And this is going to equal 32. Now if I want to know the radius, r squared is 32. So I'm just going to take the square root of 32. I can simplify that if I need to, but I'm not, more than likely they're going to ask you for the equation. So let's move on to the next problem. You are given a random point and asked to determine if it lies on the circle. Most of the time you're probably going to be given a bunch of points, but let's go ahead and fill this in. I have my HK sitting right here. So I'm going to start with my skeleton. X minus squared plus y minus squared equals r squared. So I have a +5, I just put that in, and a -6. So I'm going to change my sign and put a 6 there. Now, 14 squared, if I plug that into my calculator, I get 196. And that's what's going to go over here. I need to plug in the point that's given, just kind of like we did when we found r squared. I'm going to go ahead and fill it in like this. And I have to check to see if the new point is on there. I'm plugging in a -9 and a -6. So when I do that in my calculator, parenthesis, -9 minus 5, close parenthesis squared, plus -6 plus 6, close parenthesis, squared, equals 196. So let's see. Oh, I got 196. So when I plug it in, I get 196 equals 196. Is the point on the circle? I'm asking, are these two things equal? The answer is yes. That point happens to be on the circle. Now we've concluded everything we need to worry about with circles and the formula sheet. So what we're going to do now is we're going to move on to what happens when we have circles with lines in them, and we have to figure out what we're asking for. Now, the first thing we look for in this case is when I'm finding angles and circles. It's all based off of where the vertex is located. Now, the vertex of these angles is located where these points are at, and I can highlight them so you can see them a little bit better. This point here, this point here, this point here, and this point here. I like to remember these based off of where they are. This one's on the center, and we call it a central angle. Don't forget, this little mark means angle. This guy, the vertex, happens to be on the circle. I like to call that a projector. And I think of a movie theater projector because when it goes farther back and it gets really big, the movie screen is really big, but the piece of film that you're looking at is really small. When it's on the outside of the circle, I call it takeout. And in math, when I think of takeout, of course I think of subtraction. And finally, when it's inside the circle, I call that a plus sign. Because if I rotate it, it's going to look like a plus sign. So what do I do with these? One of the biggest things I like to remember is wherever this vertex is, if I'm looking for an angle, you see the guy pointing? I kind of like to think of a flashlight shining. And if he was shining a flashlight right here, if you look at the lovely flashlight picture here, it's only hitting a certain spot. So that's what's going to happen here. This angle, if he's shining a flashlight, it's only going to hit this arc right here. And what I know about a central angle, if it happens to be on the center of the circle, and the arc, they happen to be equal. The angle equals the arc. Now if I take the flashlight and I shine it here, it's hitting this part of the arc. And I know that the angle equals 1/2 of the arc, or the arc equals 2 angles. So it's up to you to figure out which way you need to go. If I'm going from small to big, or from big to small. Next, now if I take it out and I shine my flashlight, this guy's going to shine here and here. There's actually 2 angles, or 2 arcs that he's hitting. So an angle equals 1/2 the big arc minus the little arc. And when I look at that, I can also write that, because you know there's 2 arcs, I could say 2 angles equals the big minus the little. And just like anything else, I actually, if this is where I start, I go as far away as possible, and that's going to be my biggest arc. Now the last one. If I look at the plus sign, it depends on which way I'm going. If these are the angles that I'm talking about, and I shine it, it's going to look like kind of like Darth Maul's lightsaber. I'm going to hit these 2 arcs. If I'm hitting the other angles, and I can change my color of my highlighter, if I'm hitting here and here, the flashlight's going to hit the purple arcs. So it kind of depends on what's going on, but it's also going to be 1/2 arc 1 plus arc 2, depending on which way we go. So let's look at some examples. So for our first example, I have to ask myself, here's my angle. Where's my vertex located? My vertex is located on the circle. So if I remember right from the last slide, and I'll pull it up, this is what I called a projector. So if I'm looking, I want to see where that flashlight is shining. The flashlight is shining here. So if this is 28, I got to get bigger, times 2 is 56. So arc JM is 56 degrees. Now it didn't ask me about arc JM, it asked me about angle JKM. Now I start at J, I go to K, and back to M. So I would be shining on the same exact arc as 56. So when I pull that back, 56 divided by 2 is 28. So this happens to also be 28. So let's look at the next example. Oh, if I look at my vertex, this one is inside the circle. So if I check out what we've already done, I call that plus sign, and I have to add the arcs together. So let's look. Here's my X. Let's see where my flashlight is shining. It's shining on the 60 and on the 20. So I know my angle, my X, is going to equal 1/2 of 60 plus 20. Now let's say I can't do that. I can always go over to my calculator, hit second y equals, put in 1/2, do exactly what you see here, parenthesis, 60 plus 20, and I get 40. So what does X equal? X equals 40 degrees. Let's look at our next example. I'm asking myself, where's the vertex? It looks like it's outside the circle. So if I look at what I wrote down here, I'm going to set up my equation now. I'm going to also shine my flashlight from the 38. And I'm going to say I go as far away as possible. I get 180. I subtract X, and it equals 38. Now I could do 1/2 of all this, or like if you look what I wrote here, I could also say 180 minus X equals 2 times 38. I can do that in my calculator. 2 times 38. And what do I get? 76. From here, I'm going to go ahead and subtract 180 on both sides. I'm going to get 76 minus 180, or negative 104. So negative X equals negative 104. They both have a negative sign, so X equals 104 degrees. Now, let's say I had no idea how to solve that equation because it's the SOL and I kind of forgot everything. I could go to y equals and type in both sides of the equation. I'm going to try to look at where my wall is and type a few things in. Under y1, I'm going to type in alpha y equals and go ahead and put in my 1/2, parenthesis 180 minus X. On the next line, I'm going to type in 38. Now, if I can do it two ways. If I hit second graph, I get a table. Notice I'm already at 20. I'm trying to figure out where this thing is going to equal 38. And it's slowly getting there. And this might take a while if you're doing the SOL. I can also hit second table set once my computer catches up with me, and change this number to whatever I want. I'm going to go up probably by 50s. I was already pretty much there. Check what's going on at 100. And amazingly, at 104, they're both 38. So where do they match? When X is 104. That's kind of like my cheating way to solve an equation if I kind of forget what I'm doing on the SOL. So let's go on to the next set. Now, this is a little bit different. I'm not looking for an angle anymore. I'm looking for segment lengths. Now, one of the biggest hints to this is there are going to be no degree marks. If there are no little degrees, like 58 degrees, none of those, then I know I'm probably looking for segment marks or segment lengths. Now, there's really only two formulas for this that you have to remember. And once again, I base it off of where my vertex is. If I'm sitting here and I have this ball, and this ball hits a guy in the head, it's going to pop him in the head. That's how I remember it. It pops him in the head. Now, what does that pop stands for? It stands for product of the pieces. And I can take my two segments and I'll color code them a little bit. I have my purple segment and I have my, and I'm going to change it to orange, my orange segment. Now, I know this could be a little confusing, so I'm going to try to put numbers on them. If I have a 5 here, a 3 here, an X here, and a 2 here, I'm going to actually go by my purple segment or my orange segment first. My orange segment. That's what I'm going to look at first. When I do that, I get a 2 and an X. And what's that going to equal? Well, my purple segment, which is a 5 and a 3. Product means multiply, so I just multiply them together. Once I set up my equation, I can solve it. We're going to go over examples later. I just didn't want to confuse you by putting letters A's, B's, C's, and D's in there. So let's look at the next slide over here. This one says ow. Think about it. If I took a vertex that looked like this and I hit someone in the head with it, it's probably going to stab them. They're going to be so hurt. They're going to be screaming, ow, ow. So I'm going to do the exact same thing, and I'm going to tell you what it stands for. The O stands for the part outside the circle. And I'm going to multiply by the whole segment or the entire thing. So O times W equals the part outside times the whole thing again. So I'm going to color code these things. We're going to have an orange one, and we are going to have a purple one again. I'm going to put some values on here. Let's say, and I'm going to put some, I don't want to necessarily put too many numbers, but let's put a 5 and an X and a 4 and an 8. I'm not going to solve these. I made those numbers up just like I did for the last example. So let's go ahead and look at the orange segment. And the purple segment. So when I look at the orange segment, now this is where I'm going to get a little tricky. I'm going to actually outline my circle and probably shade it in a little bit, because this is the part inside the circle, and I'm shading the inside so you can see it. So if I look at the orange one, the part of the orange that's outside the circle is 5. The entire thing is going to get a little tricky, but the entire segment, I got to figure out how big that is. So I'm not quite sure what to do here, so I'm going to just leave it as parentheses for right now. I'll come back to that, and let's look at the purple one. The part outside the circle, because it's not in this big green blob, is 4. The entire thing is this whole thing right here. Well, the part outside's 4 and the part inside is 8. 4 plus 8 is 12. So the whole thing is 12. And I added together. Now, on the other side, I have a 5 and an X. So I am going to have to add those together. I'll go ahead and make it orange just so everything matches. 5 plus X. So let's look at some actual examples and do some solving. So as we look at our first example, let's see what we're dealing with. I have to match it to my chart a little bit, and I see that we're going to be working with the product of the pieces because I would pop someone in the head. I am going to color code these once again. I have an orange and I have a purple. So when I color code them, I'm going to keep with the orange and the purple, and let's go ahead and see what I'm working with. On the orange line, I have a 3 and an X. On the purple line, I have a 9 and a 5. So I'm going to go ahead and multiply. 3 times X is 3X. 9 times 5 is 45. I divide both sides by 3, and I get X equals 15. So let's go ahead and look at the next example. When I look at the next example, I notice that if I were to do anything, I would throw this ball at someone, that would really hurt someone. That would make them say, ow. So let's look at what I need to do. I'm going to color code these segments again. I have an orange piece and I have a purple piece. So when I look, I have orange and I have purple. And I know that they're equal. So let's go ahead and write these in. First, orange. The part outside the circle is an X. The entire segment, the entire thing, well, none of it goes on the inside. The entire thing happens to also be X. And what does that happen to equal? Let's look at the purple part. The part outside the circle is 2. The entire thing, I have to add together. I get 16 plus 2. So let's go ahead and do some math. And I know when I multiply an X times an X, I get X squared. Now, this is going to be 2 times 18, which happens to be 36. Now, if I didn't know any of that, I could easily go over to my calculator and type in 2 times 16 plus 2 and get 36. Now, when I have an X squared, I need to take the square root of both sides. When I take the square root of 36, I get 6. So X equals 6. So let's look at one more type of problem with circles. And this is definitely like SOL cheat time. If all else fails, what you have to remember is if it looks equal, it probably is equal. So here, this is just a form of ow ow, but they're both on the outside. There's nothing on the inside of the circle. When that happens, I can just set these two things equal. And don't forget that I could always pull out my compass. Now this is not what your compass on the SOL is going to look at like, but I know that I have a point in my compass. It's actually pretty close right now. And I could check to see that they happen to be the same length. Now granted, everything might not be drawn to scale, but I'm going to go with this. Now, what would I do to solve this problem? I could add 1 to both sides. I get X squared equals 25. I need to take the square root of both sides, and I get X equals 5. Let's look at another example. Now this has these congruent hash marks. That's kind of a hint to me that they're probably equal. So I'm just going to set them equal. Now, here's my wall. and I need to move things around. I'm going to subtract x on both sides, and I get x equals 40. And I'm done. Let's look at our last example. Now this one looks a little tricky. I know that the x's are the same, but what you have to remember is the SOL, their favorite thing to do is to throw some kind of a right triangle in there for you. So if I look at this right here, if I see a triangle in another picture, generally I know I'm probably going to be looking at some kind of SOHCAHTOA if I'm looking for an angle and a half sides, or if I'm looking for a side and a half angles, which is not the case here. Or their favorite theorem, and this is also from your formula sheet, is c squared equals a squared plus b squared. At least that's how I like to write it. So when I look at this, this looks 90. The one across from my hypotenuse is my hypotenuse across from the 90-degree angle. And this is just x plus 16. So when I do this, I'm actually gonna write it c squared equals a squared plus b squared. That's my preference. And I'm gonna get x plus 16 squared equals x squared plus 32 squared. Now I have a couple of different options here. This looks like I might get way confused on the SOL. So I'm gonna come over here, back to my drawing board of my y equals, and I'm just gonna type in both sides of my equation. It's important to notice here's my equal sign, and I'm gonna write in parentheses x plus 16 squared. And I'm also going to write in x squared plus 32. Oop, I forgot the squared. 32 squared. Now, I'm going to double check these numbers, make sure I'm right. X plus 16 squared, x squared plus 32 squared. I haven't really done any big math here. I'm going to hit second table. I'm at 100. I can see these are way big numbers. Second window helps me start over. I'm going to start at 0, just for the sake of starting at 0, and go back to second table. Now, these are still big numbers, so are here. SOL time, it's untimed. I can sit here and I can scroll to try to see if they're going to match forever if I wanted to. Now, I see that right here, they're both 1600, 1600, and where does that happen? X is 24. Now, in case I didn't know how to do that, I could also solve it this way. This is going to be x plus 16 times x plus 16. Now, when I was in Algebra 1, I learned FOIL. When I multiply the first two, I get x squared. When I multiply the outside two, I get 16x. The inside two, also 16x. And finally the last one, 16 squared. Well, if I'm not sure, let's go ahead and put it in my calculator, and I get 256. Now on this side, I'm going to have x squared plus 32 squared. When I square 32, I get 1024. So now let me go ahead and combine my like terms. I'm going to subtract x squared on both sides. These disappear. These disappear. I get 32x plus 256 equals 1024. I'm going to subtract 256 on both sides. I'll do that in my calculator. 1024 minus 256. And I get, I'm going to actually write it somewhere else up here. Maybe right here. 32x equals 768. I divide both sides by 32, and x equals 24. Now granted, this was a whole lot of work. If nothing else, especially SOL day, I would do the most. I would probably try to FOIL and figure out that x is 24, and I check it in my calculator with the table. So go ahead and try a few problems.